Alright, this is my last video on dynamics, and I'm going to be looking at force and time graphs. Okay, so we're going to be looking at the relationship between force and time graphs and analyzing any information we can gather from that. And there's plenty. So let's have a look. The area under the graph is the force time graphs, which gives us the impulse of the force applied to it, hence the change momentum. So the area under force time graphs gives us the impulse of the force applied. Okay, remember the units for impulse, it's Newton seconds, and that's what the two of those axes are labeled. Okay, so this example here for this slide, I've got here the impulse of this is the area under the graph, which is 2000 kilograms meters per second for momentum, but impulse is Newton seconds. Okay, so it's the same answer, just with Newton seconds. Now I've got here another question that I'm going to answer in a bit more depth. So the graph shows how the force acting on a 3 kilogram object can be changed over time, and the object was initially at rest. So A, B, C, and D. Let's have a look at them. A, use the graph to find the change momentum of the object during the first 8 seconds, and it's the area of the graph. So 6 newtons times 8 seconds, and you get 48 newton seconds south. Okay, or if it's momentum, it's kilograms meters per second south. Okay, B, determine the velocity of the object after 8 seconds. So it's F equals ma. We want to find velocity, which is the same as acceleration over that time period. So it's 48 divided by 3 will give us 16 meters per second south. Now for C, we have what is the total impulse applied to the object. So it's the area under the graph, and there's two different areas. We've got 6 times 8 plus 12 times 8, which is 144 Newton seconds. What's that final velocity? It's 144 divided by 3 kilos, and you'll get 48 meters per second. And for E, what constant force acting on the object for 16 seconds will cause the same impulse? Then you do 144 Newton seconds divided by 16 seconds, so it needs a constant force of 9 newtons. Alright, that's a very simple force time graph explanation. I'm going to do many more questions in class, so we'll focus more in depth in the class aspect, and this was just one of those examples. So thank you for watching. I'm going to now put a link in my video for Module 3, Waves and Thermodynamics. Thanks for watching Dynamics. If you haven't subscribed, please subscribe.